So this is not a talk about tools. This is not a talk about technologies. This is a talk about culture and about processes. It's a talk about people, basically. And we have to remember that the systems that we build are built by people. And if we look at the systems, then we tend to see that the systems are usually built, around the same rules and around the same things that we see in the cultures that build them. So it's very important to understand that if we want systems and processes to be reliable, we have to work on the culture behind them. And this talk is somewhat about that. Some of this talk is going to be pretty obvious. I hope so, anyway. If it's not obvious, then we're doing something terribly wrong. But there is a gap between what we know or what we think we know and what we actually do in practice. So try to look for those things in this talk. Another thing I want to say is that most of the people in this room probably are from the web industry. Am I wrong? I hope not. Anyway, in the web industry, we're focused around building services instead of products. We hear a lot of stuff like SaaS and web services and that kind of stuff. And when you're building a service as opposed to building a product, the operations of that service is a big part of what you deliver to the customer. It's a big part of basically the business value that you have. So I, as an operations person or guy or whatever, feel that, I should be focused about the business. I should be focused on that. Have you ever seen this? Have you ever heard something like this? And be honest. Anybody who said something like this, raise his hand or her hand. So a few of you are honest, I guess. Not as much as I expected. But the thing is, we know this is untrue. Everything breaks, and this is just a fact of life. And when things do break, people tend to act like this. This is very common. But we should be feeling like this. We should be feeling greedy, because although downtime is pretty bad and it's costing us money and it hurts the company and there's a lot of damage that's going on and so on, incidents should also be thought of as an opportunity. It's a really big opportunity, because this is when we find out for real how a system behaves in situations we haven't thought about, we haven't planned for. And this information is just so valuable. It's golden. It's information that is sometimes impossible to obtain in any other way. And we wouldn't think about getting it. We wouldn't think about simulating those situations or disasters. There's so many things that could cause a fault or a disaster, and we just can't get that data in any other way most of the times. Some faults are obvious. We know about them. We can try and simulate them. Sometimes it just costs too much to simulate the disaster. So we need to monetize those incidents as much as we can. And we're going to come back to this later, because one of the things that we understand, or at least eventually we understand, is that incidents are critical to building a reliable system. But when there is an incident, during an incident, nobody wants to hear about this. You try to explain that it's an opportunity, and people say something like, forget this. Just bring the system back online. We don't have time for your bullshit. And the obvious solution would be to get a really good ops guy or a really good ops girl or team or whatever you have, and just throw them at the incident whenever you have one, and hope they do the job very well, and the system's going to be up as soon as possible. Basically reacting to incidents. And this doesn't work in practice, because even the best ops team can't do much if they don't have tools in place, and if they don't have fallbacks, if they don't have recovery patterns, if they don't have experience with the actual system. And all of those things are things that needs to be obtained and prepared before there's an incident. Basically, it boils down to the fact that reliability is a long-term effort. It can't just be a reactive pattern. You can't achieve reliability by reacting to events. You have to work at it all the time. You have to consider it as a long-term effort, as a cost that needs to be actively managed. It's part of the development cost. It's part of the cost of building a system, basically. And for that effort, basically, real-world experience is critical. You can't build a reliable system if you don't have real-world experience. And this is one of the main reasons why having incidents and gaining that experience is so important. So this effort basically is composed of preparing when things are normal and you have time to prepare and build your system and stuff like this, handle disasters when they happen, and then afterwards try to learn and improve as much as possible. And to cycle, just keep doing it. Rinse, repeat, that's the basic idea. And the first thing that you should consider when you're talking about preparing is that you have to be honest, basically. People tend to make exaggerated business requirements, and this is something that I'm sure you've all encountered in a lot of places. I know I've seen this in a lot of companies. You go to someone, you're sitting in a design session, and someone says something like, "We can't have any downtime." I'm sure you've all heard this. We can't lose any data. Absolutely not. No way. And when you start drilling down into it, and look for the assumptions beneath that guideline, you'll often find that you can't validate that assumption. The company can lose data. The company can have downtime. And sometimes, the numbers just don't add up. I've been to companies where they could tolerate hours of downtime, but they still spent millions, literally millions of dollars on preventing any amount of downtime. And the end result is that if you don't prove your assumptions and you don't try to validate them, then you end up with a system that is more complex than it should be. You end up with a system that is hard to maintain, and it will break more often because you try to make it so robust. So just by being honest with yourself and validating your assumptions, you can have a system that costs less and probably not as likely to fail. And once you've designed the system and you built the system, you want to practice disaster handling. You want to practice your processes, your emergency process and everything. Because the way you discover what your skills and what your tools are really worth is by practicing. I'm sure that you all have logs, you all have monitoring, you all have metrics, but are they really going to help you find the fault in production? I'm not so sure. Because my experience is that logs are crappy. The metrics never measure what you need them to, and your monitoring never covers what you thought it covers. Because people don't practice. They don't try to debug their system with those tools. And once you try to do that, you find that your monitoring is lacking. So just because you have the tools doesn't mean that you're using them effectively. Doesn't mean that you have the right tools. So you need to practice to understand this. Also, there's this issue of rarely used skills. Recovery skills are basically skills that you use on rare events, where the system breaks. How often do you recover a database? Some people do it often. A lot of people do it very rarely. And if you do something very rarely, then your skill is not very good. And you're relying on this skill in times of crisis, when there's a lot of stress. So you need to make sure that you keep the level of that skill, let's say that the inadequate level. Another thing is disaster recovery plans and decision lines, stuff like this. Once you're practicing processes, then you should measure the time it takes to execute a process, the effect this process have on your system, the side effects it might have, stuff like this, because this information, you can use that information basically to build plans that you can reuse. You can test those plans when you have time, and you can make decisions beforehand and have those decisions at your disposal when there's an incident and you don't have a lot of time to think about stuff. And of course, simulation. The thing is, and I don't know, do people know the Jepsen project? Okay. Great. So if you haven't heard about it, it's basically a project by somebody named Kyle Kingsbury. He's also the author of Riemann. And what he's doing is taking databases, distributed databases, and he's breaking them by applying network partitions to databases. And basically he sees what's going on. And the results are scary. Very interesting, very scary. But the thing is that systems don't behave the same way when they have issues, when they have stress. They behave in radically different ways sometimes. Some bugs are only exposed when you have stress or disasters. And you're not going to find those bugs. They're going to hit you when it's the most inconvenient time. So you need to simulate. You have to simulate, and this is also a very important source of knowledge. And this all leads me to something we call the faulty fallback syndrome. Basically, fallbacks are the process that we use, that we rely on to save us from trouble. If the database failed, then we have this failover process that brings the slave back online, and everything should be okay. But it turns out the fallbacks fail much more often than people expect them to. And the reason is that sometimes people don't even test the fallbacks, and when they do test the fallbacks, they test them in the lab. So the good example, if we follow up on the database example, is that you have a relational database, and the master just broke down, and now the slave is coming back up. But the master was warm. And we know that relational databases, heavily loaded relational databases, for example, take up to a few hours to warm up and reach their full performance. So you fall over to your slave database, which is cold, performance is not good enough, and the system breaks. Now, of course, in a lab without any load, this would work perfectly. So this is a really good example of the faulty fallback syndrome and why you should simulate. And of course, processes, it's obvious that we should improve them, and it's obvious why they should be common and why they should be contained and independent and why we want to limit the amount of damage they do. The thing is that some of those processes we use for emergencies, some of those processes we use every day, and if that's the same process, that it's even great, it's even better. Because systems basically are like a chain. If one part is very reliable, but another part is not, and if that part is in the critical path, then the whole of the system is not as reliable. And we have to look at things holistically. We have to look at what composes the system. We have to look at the entire system, not deal with one part of the system. People tend to invest a lot of money in making one part of the system very reliable. Databases is a good example again. Firewalls, load balancers, but they tend to forget other parts like processes or people. The thing is that when you look at the human factor, A is not a part of the system, and it is. We are a part of the system workflow. We are another component in the system. We've built the system, but we also operate the system. We interact with the system. We can't ignore our part in the workflow of the system. And the second thing is that we tend to forget that people are not very reliable. People get tired. People make mistakes. There's only so much we can put in our heads. We have limited mental capacity, and we want to manage that. We want to reduce the amount of mental overhead that we have. So standardization, for example, is a very good tool. It's a good tool for improving reliability in other aspects also. And this is something that we really want to have in places. It reduces the amount of places you have to look for logs, for example. Another good example of this is using the same tools in development and production. And although this might seem obvious, people don't do this. You go to a company, you ask, how are you deploying? Well, we're using Chef. And how are you deploying to your development environment? Maven. That doesn't make sense. So as much as possible, try to consolidate and reduce the amount of tools you need to know, the amount of tools you have to maintain and have skills with. And if you're treating the human factor as another component of the system, then it should have redundancy, like your database or your firewall or whatever. For example, if I'm the one that's going to be on shift today, then who's my backup? What happens if I fail? Someone should back me up. I have a laptop. All my tools and certificates and keys, SSH keys, whatever, on my laptop. Can I still operate the system without my laptop? What happens if my laptop breaks? And this actually happened to me twice. And I survived because I'm paranoid. But that's not really the point. So we need to think about those stuff, and we also need to manage wear and tear, fatigue, basically. If I'm going to be on shift today, then I should go home early, and someone has to make me go home early, because I could be working again today. And personally, I found that I work until 10 p.m. and then I go home and the system breaks at 11. So I'm probably not being so honest, I guess, but that's just real life. So people tend to think that we're paranoid, that ops in general are paranoid. You usually spot them by the fact that they're wearing those tin hats to protect against the NSA, or checking their cell phones all the time because they expect something to break. But the thing is, we're not paranoid, really. People are out to get us. The system is out to get us, basically. If you think about what it takes for a system not to break, it means that every single thing in the system has to work. Statistically, it's just impossible. Things have to break sometime. If that's not enough, we're actively breaking the system by pushing bugs into it. So yeah, people are out to get me. The developers are out to get me. I'm out to get me. It's horrible. I'm not that crazy anyway. But anyway, in real life, things do break, and they usually break at around 3 a.m. I don't know why. Actually, I know why. In Israel, things break at 3 a.m. because we're geared towards the American market, and the time difference is such that peak hours in the US are 3 a.m. Here in Israel. But things also break at 3 a.m. in the US too. How come? That doesn't make any sense. So the reality is that things break all the time. They break at 10 a.m., they break at 11, they break at 3 a.m., they break at 4 a.m. But we only remember, we tend to exaggerate in our minds the things that happen at 3 a.m. because it hurt us the most. It's the most annoying thing that your pager rings at 3 a.m. If it rang at 10 a.m., then, well, what the fuck. So this is another bias, by the way. And Lindsay's talk was absolutely amazing, by the way. And I know what you're thinking about this. You're thinking about, hey, this guy doesn't use the cloud. No wonder he's screwed. So in reality, the cloud breaks as well. Everything breaks. And when things do break, make sure that you don't panic. And this seems obvious, of course. But people tend to handle the systems when they panic. They do. And there's a lot of stress that is associated with disasters. And if you're not accustomed to that stress, and you start handling the system, you're going to make stupid mistakes. It's inevitable. So just don't. Have your backup do this for you. Just relax, drink something. When you're up to it, then start handling the system. And another thing that helps a lot with this is to assign an incident manager. Again, people don't do this. You want somebody to take the pressure off, basically. That's a general idea. And it boils down to doing a bunch of managerial tasks like watching the clock, taking care of your decision lines that you had that you made previously, keeping communications running within the team, from the team outside to managers to customers. Somebody has to do this. You want to maintain an incident log so people can get up to date very easily without having to ask all the people that operate this who did what. Why did you do this? Stuff like this. And you have to remember that some incidents can take a long time, and you have to prepare a handoff. And somebody has to do this. And this is a really good feature for your manager if you have one, because this is what he knows how to do, or her. People manage. That's what they do. It's also, there's a great benefit of using your manager for this because it takes the pressure off. It makes him part of the solution instead of being part of the problem. And again, if we're talking about biases, when you have an incident, then you wake up, you start staging to servers, and you start restarting things immediately. Maybe this is broken, maybe that is broken. And this is not the way. Never act without evidence. Because if you make assumptions, then you're prone to biases. And there are a lot of biases, as we've seen. And it will lead you to wrong conclusions. And it's actually better not to do anything most times and try to analyze than doing something that you don't have no evidence or reasons to believe will help. Some incidents actually resolve themselves. This could be the case. So although it's psychologically very, very hard to sit idly by and do nothing, this is exactly what you should be doing before you collect data. And this is the first thing you should do. You should collect data, always. You need this data for analyzing the issue, but more than that, you need it to monetize on the issue. If you don't collect data, if you got out of an incident without data, you've gained nothing. So you have to make sure that you collect data and try not to taint it as much as possible. Do one thing at a time. It helps with correlation. It helps tremendously. And if you have more than one people in your team while operating this, then you have to communicate. And chat services are very good for this. But you need to make sure that you log the chat and that the log is available to anybody, and that anybody can join in. Anybody who thinks they can contribute can join in without the need for invitation. And now that the crisis is finally over, we want to know what happened. We want to analyze what happened and try to get something out of it. And this process is called postmortem. Again, people don't do this as not enough. They don't do it as much as they should. There's a lot of information about postmortem. You can read, you can look it up on the internet. There are a few methodologies for it, but make sure that you do this. And a postmortem is supposed to culminate in something called root cause, but it's not a very good idea, because root cause basically leads us to believe, semantically, it leads us to believe there was only one cause for this incident. And the fact is that most incidents have multiple things that contributed to them. So it's better to think about contributing factors and not about root cause. It's misleading otherwise. Especially if you're talking about complex systems, there's more than one thing that could have caused this. There's an interaction going on. There are multiple things that could have prevented this, and so on. And since we're talking about a complex system, it's no one's fault. This is true for all systems, by the way. Fault, blame, usually makes people hide information. It makes them uncooperative, and it's basically a bad idea. Try to have a culture, especially in postmortems, where people don't feel this is going to end up, this is going to result in pinpointing someone and saying it's his fault. And if you are in a culture that already does this, then take the blame on yourself. It's a good tactic. It basically opens the door for a productive discussion. So, that's something you should think about. And once you have results and you decide that you need to fix something, make sure that you actively reduce technical debt. You follow up on this root cause. People tend to say that, oh, well, we found this, there was a problem, we need to fix it, it's a known issue. And then they never fix it. But the thing is that those problems interact. And the more problems you live in the system, the greater the chances of interaction are. So to summarize, reliability is basically about trust. It's a sentiment. And to establish that trust, we have to have experience. It has to be real-world experience. And people will not use features in the system. They will not use options in the systems if they don't trust, if they don't believe that those options will work. They won't activate those options. So we have to establish that trust. And it basically boils down to the fact that if you're not confident that your system can take a hit, then you don't have real reliability, don't have actual reliability. Even if you have the best ops team in the world, it's still a long-term effort. There's no way to achieve reliability without that. Doesn't matter how good your ops are. And if the system hasn't failed ever, then paradoxically, it's not reliable, because you know nothing about the failure modes that the system can have. You have no idea how to simulate. You have no data to compare the simulation to. You don't know if the simulation is even relevant. And people, this is called assumed reliability, and people build on top of that. If there is a component, say a database, that they think will never fail, then they're going to put all of the data in that database. And when that database does fail, the damage is going to be horrible. And when that database does fail, nobody will know how to operate it, how to bring it back online, because they never did it. It never failed. So paradoxically, incidents are tremendously important for reliability. You can't have a reliable system without incidents. So thank you very much, and I wish everybody a lot of uptime. Hope your system never breaks. Questions, anybody? Yeah.
I think it's less of a question, more of a point. You mentioned before one of your I mean, the post-mortem shouldn't say it's that team's fault, but it should say, one of the contributing factors, one of the reasons we broke is that, here's an error condition in the system owned by that team. So that team is now has an action item, now is responsible for fixing that specific issue. So there needs to be a culture where, no one assigns blame in the sense that, it's your fault, but there is acceptance of results, of responsibility to the issue.
That's true. There's a difference between assigning responsibility and assigning blame. The thing is that naming somebody who has to do a certain task doesn't make him the culprit, doesn't make it his fault. It's true that in some cases it is somebody's fault. Sometimes you have an idiot and you can't escape that fact. But the post-mortem is definitely not the place, to do this. If you have to do this, then take it outside, do it 2 weeks later or whatever. I found that in many companies they don't have that distinction between responsibility and blame. So it really depends on the culture in your company, I guess. Anybody else? Okay, thank you.